Maharaj. Okay. Everyone, what was the value? A. No, from the beginning. AR equal to.
0.7333.
What was the last thing I wrote? I wrote A theta. A theta equal to A multiplied by. Okay. Then I said A equal to.
0.847.
Okay. Then I wrote AR equal to A sine 30.
Yeah.
Then I wrote AR equal to. Sorry. I mean. Yeah. Sorry. AR equal to.
Minus 2. Sorry. 4264.
Okay. I don't know. Cannot be. Okay. Now that you have got a value of no, it cannot be minus Bahadur. So summation of forces.
R is 0. And if you calculate, it's minus.
Huh? No, AR is A sine 30, right? A you calculated, this is sine. So summation of forces is equal to MAR. Now you will go back and you will start writing N cos 30 minus mg sine 30 is equal to MA sine 30, right? You can see here. And finally, you will have N equal to 1. Okay, give me the value. I don't know. Just give me the value. Okay. And then I will say summation of forces in the theta equal to MA theta. So I will have minus N sine 30 plus F theta minus mg cos theta is equal to MA cos 30. And you can also get the value of F theta. Okay. 1.23 Newton. Okay. 1 point. Now let's see the free body diagram which I lost. So, this is what I got. This is the radial direction. This is the theta direction or E caret theta. And this is E caret R. And this was my object. And this is the mg. This was the normal. And this was the F. The F was in the same direction as this one. So F theta. Let me use F or F theta, whatever. You can call it as simple F and you can call it as simple F if you want. Okay, let's read the question and then I will answer his question. The question said the slotted arm OA rotates about a fixed axis through O. At the instant under consideration, theta equal to 30 degree, theta dot is whatever, theta double dot is whatever. Determine the forces applied by both arm OA and the sides of the slot to the 0.3 kilogram slider B. Probably it's not even 0.3, whatever the weight is. Neglect all friction and let L equal to the value. The motion occurs in a vertical plane. So you had to find the forces applied by both the arm OA and the sides of the slot to the slider. So the arm, if this is the that fellow, the arm does the F theta, right? That's why you calculated the F. The sides have the normal force, right? Ah, you got it. Is it clear? Why?
Is it a easy problem?
Huh?
That's the problem we did well.
Oh, it's very easy. Hang on. Let's go step by step. Let's go step by step. What was the question? The question was that you have the arm, you have that slider or whatever. The arm is trying to move that fellow, correct? When this arm is moving, in which direction would it apply the force? 90 degree to it, right? So technically, when they are asking the question of finding the force on the slider by the arm, they are trying to ask me what's the F theta, the force in this direction that just is putting it to it. That's why you see when I am doing that summation of forces in the theta direction, I put a capital F on the left hand side because I know that there is a force that the arm is putting on this fellow. What about the mg? For sure, it is in a vertical plane. There is a weight component to it. What about the n? The fact that this whole object, where is the figure? I don't have the figure right now. The fact that this whole thing is moving in this slot, the wall has to come up with a normal force, right? And that's why in the free body diagram, if you see,
The forces are okay, but we found the velocity and acceleration.
well, my point is that when you are writing the summation of forces in the radial and theta direction, you have to find AR and A theta. In order for me to calculate AR and A theta, I need to know them, and I don't know all the quantities. So that's why I need to know the A. So that's why I first found the VR, the V theta, the A, AR, and everything. Anyways, you will look into the solution yourself and ask me any further questions. So we first found the V, then we found the R dot, then we found the A theta. From A theta, we found the A, then from A, we found the AR. So we found the V, then we found the R dot, then we found the A theta, then we found the A. This is how we proceeded. Anyways. Sir, I emailed you about homework 8. What exactly did you email me about homework 8?
He submitted the homework a little late, I think.
When did you email me? I don't know. We will talk about later. Any questions for me? It's not clear. The whole thing is, it should be clear. You have to crack the AR and A theta, and that's why you have to go through the drill. Okay, do you want a break or should we continue? Okay, we can have a 5-minute break.
Please move it out so that we can.
The question is gone, by the way.
The question is,
Should I open the question?
no need for the question.
Lord? ऊपर की तरफ ऊपर पुश करना है तो ऊपर मतलब ऊपर इसलिए पुश करना है ये खुद से इसको असल में 90 डिग्री में पुश कर रहा है ये रॉड जो है पुश तो नहीं लेती रॉड इसको 90 डिग्री में पुश कर रहा है लेकिन क्योंकि स्लॉट ऐसे बनी हुई है because the fact that the slot is like this, that's why even when it is pushing it at 90 degree, the fellow is moving there. So exactly. So for example, if I'm putting a load like this, but there is a slot like this, so the force is applying at 90 degree to the object, but the fact that you have a slot, the fellow has no option but to go up. If it had to go most efficiently, it would definitely go at 90 degree because if you are applying a load on something like this, the thing will go at 90 degree. But just imagine I'm putting a load like this, but I have put a slot. The force is being applied at 90 degree, but the slot has no option but to go up.
Like it's with little contact with the other one. Like
There is a contact. No, there has to be significant. There has to the left wall. There has to be significant contact because the thing is applying at 90 degree force, and there is a wall that is stopping it from going there, and it is directing it up there. That's why you calculated a capital N that is given by the wall. Are you sure? Look.
Yeah, got it.
Sure.
Like the thing is, it has to be stuck to the wall to go up.
Exactly. So that's why you see when you found the normal force is not coming from the right hand side of the wall. It is coming from the left hand side of the wall. Although the wall is on the both sides, but when the rod is making it move, it's the left side that has to offer. Okay.
Future, I have another question. Like there's the same scenario. Cylinder is here, and this thing is moving there. Okay, so what will be the normal force? Like this is moving this like here, and what will be the normal force?
So for example, when you have to make a free body diagram, don't leave this much money. You will put the arrow of this wall from the left to the right, because when this is a ball kind of a thing, whatever, slot in the cylinder in a slot. So when it is going like this, you will put an arrow like this.
What do you like this?
Like
Normal
this.
force, right?
Right here.
Here?
Right here.
Like
Take
exactly like
like
90 degree, right?
90 degree to this, because
90 degree to the cylinder.
The force exerted by this on this 90 degree. 90 degree.
And nothing with these walls, these things.
But you think the point is you are coming to the hypothetical question. If you have a correct diagram, it's easy for me. But I think but you will have to think about it. But I think one force is from here. This is complicated. नहीं अब इधर भी wall है सोचना पड़ेगा.
I try to
Go to see a question and probably. Now on that note,
what if you found all the loss like this? Derivative of this. And then put the value of. So
you found the derivative of this like this.
Yes.
Oh wow, correct. Okay, are you sure? 1 over cos theta is, what is the derivative of 1 over cos theta? Sure? Like you are 100% sure of this,
we
right?
are not 100%.
No, about the derivative. 1 over cos theta derivative, you are sure, right?
I write like this.
Oh, I will have to perform the whole thing by opening the derivative. If let's say if your derivative from here to here is correct, and you have taken the right derivative, no mistakes here, then this is very good. How did you figure out? I'm not sure, but this is an excellent way as well. But this is also a good way.
Hocam, you didn't understand. Right.
Oh,
How you
now the
reach
problem
A?
is, 1 minute. look, this is a free body diagram, right? When you have done the free body diagram, this normal force appears because of the fact that there is a wall on the left hand side and right hand side. And when the rod is trying to move it like this, it gets in touch, in contact with the wall, right? Because there is a
Yes,
wall
uh-huh.
straight. And from here, mg is like this, 90-degree force to the radial, force is in the theta direction. When I'm trying to do the summation of forces in the radial direction equal to MAR, and in the theta direction, I get stuck because I don't know the AR. In order for me to find AR, I need to find all the values AR equal to R double dot minus R theta dot square, whatever. So in order to find the R dot and everything, I said, you know what? I will first find the velocity of the, I will first find the V theta. I know it is R theta. V theta is nothing more than the V cos theta, and from here I got the V. Then I know that VR equal to V sin theta. I saw the projections. From there I got R dot, then I got A theta, then I got. So you can see the solution as well. V is in this direction, right? It is going like this, V. So then I started making projections in V projection in R and theta direction. And I know that VR is R dot, and I know that V theta is R theta dot. Then by using V, I cracked R dot actually. R dot was the thing that was worrying me. Now that I have got R dot, then after finding R dot, I will proceed and I will say that A theta can be written as R theta double dot plus 2 R dot theta dot. This was the reason I had to find the V cos and V sin, because I wanted to crack the R dot. Now that I have R dot, I will put it here. Now that I will put it here, I will find the A theta. Now that I have found the A theta, I will use it to find the A. Now that I have found the A, I will find the AR by doing A sin theta. Your method is also correct. Okay. Okay. 13, 11. Okay, good. Have a seat. Have a seat. Okay, do this problem quickly. Don't see the equations. Make the free body diagram first. Quickly do it. The answer to your question is that if it is specifically given in the problem that it is not is a constant, the constant means that it is not changing with time. If someone says that R naught is a constant, R naught is a constant means that R naught is not changing with time. When he gave me the value of whatever that was R naught or whatever, one of the students said that R naught is 0 because I have come up with a constant. So I come up with a value. That value is at a particular instant of time. What is the guarantee that it affects 3 milliseconds or like next nanosecond? That value will not change. Right now, for example, I just told you yesterday about that there is this fellow that is rotating. And should be and at a particular instant of time, it has an omega of 2 milliseconds per second. That's it. You don't say that theta dot is 2 milliseconds per second, therefore theta dot is constant. That's what the instant theta dot is. It is quite a possibility that actually when it comes to this, it becomes super. Value is a value. Value may be constant over a period of time. So in this particular problem, for example, when the rod is actually rotating, what happens is, Abu and Mitch, when this thing is rotating, this fellow can go left and right? At the same time, Mehmet and Hussein, when this thing is rotating, the radial distance of this fellow can also change, right? So in order to solve this question, your best bet is summation of forces in the radial and theta directions. You write the equations, you have to come up with a free body diagram. And this is my free body diagram, right? The fact that you have the ground that exerts a normal force, that's your capital NC. Okay, what about this arrow, FP? For sure, when this slot is doing like this, there is a 90-degree angle to the radial direction of the rod. That's why there is a force on this little peg. We call this little fellow as peg. So FP is 90 degrees to this. There is an NC.
Is FP the normal force of P exerting on C?
What?
What is the force?
FP is the force exerted by this rod on the peg. I call it I call it FP. And whereas NC, I call the force by this, by the ground. Now, what is this 19.62? That's the weight. All you have to do is do the summation of forces in the radial and theta direction. And then you find the unknown NC and FP. So do it. Do it. We have taken it. Give me the value. It is run. Why the FP is in the theta direction? because the arm FP is 90 degree to radial, right? FP is in the theta direction because the arm is moving the peg. So the force exerted by the arm on the peg is in the theta direction. No, it's not given. Theta is given, theta is 60. Anyways, we write the summation of force in the radial and theta direction. We find the value of R like this. Then we start to find R dot and R double dot, take the derivatives. Then we find all the R dot, R double dot and start plugging in to get AR and A theta. Then we substitute our AR and A theta in these big equations that we started with. And from here we calculate NC and FP. Okay. Should we continue? Can you do it on your own time now? Because okay, you can have to. You just have to start off with the main equations. Now your only task is figuring out AR and theta, write the formulas of AR and theta. You start the problem R, you write in the form of theta, you take the derivatives to get R dot and R double dot, you start with AR and theta. Okay, everybody, I want to move forward now. I think it's here. So see this example from your textbook yourself. Okay, and let me
Just open the slide for
Thank you.
okay. Okay. Why don't you do this problem now? Okay, let's do this problem together. Okay. Do this quickly.
What is OZ?
Ounce. Ounce. OZ, 4 ounce. Convert ounce to pound mass using things like convert ounce to pound using Google. Are you sure?
That's not. 16 ounces equals 1 pound.
6 ounces of okay.
Leave the research and ounce and pound, start the free body diagram. Okay. Abdullah and quickly. Not the most critical. Make a free body diagram. Okay, that's fine. Actually, that's a good point. V square over R. Hey, just before it passes point, you have to be careful. From A, you have a circular path. Before A, there is no path. When something is not in a circular path, there is no path. You have to be very careful. B is as it passes point B. So the moment it passes the point A, it is a circular path. Then definitely it will slow it down. One minute, everyone. If I can please have your attention. Before A, there is no circular path. After A, there is circular path. No, here for example, your best bet is normal and tangential coordinates. If you go for theta dot, this question will be very difficult. Go for normal and tangential coordinates. We have it. You mean moment of inertia? Moment of inertia, I thought it was inertia. I didn't understand. Moment of inertia is in a rotational problem. We will look into it. Hang on, Hamza. So let's do it together. Okay, so we will have nice and beautiful. This is the. We have mg. Then we have ny. And you can say summation of forces in the y direction is equal to 0. So ny equal to mg. And then we will say that the RA is equal to ny, which is equal to 0.25. 0.25 pound mass. Sorry, I apologize. Pound force.
Then at point B, you can ask me the question, what happened? Then at point B, we have summation of forces in the tangential direction is equal to MAT. So you can make the free body diagram like this. At B, so this is the B. We have mg, then we have ny, then we have nn, then we have an, use a different color. This is a kinetics diagram is also included, so I am putting an with a different color. And then you have, most important, tangential is in this direction and your normal is in this direction. Now, one of the students asked me, if you are trying to use polar coordinate system, what about theta dot and theta double dot? And that's what I advised him, that cracking this problem with normal and tangential will be convenient. Okay. So now I will say summation of forces MAT equal to, who said that? Good, thank you. And then we have, because the V is constant, then I have summation of forces in the normal direction. Okay, do it. Summation of forces in the normal direction. Right, summation of forces in the normal direction. Okay, Abdullah. Okay, do it. Give me the answer.
Why is the tangential velocity constant? Where did you get that from? Because it's smooth guy.
Very nice answer from him. I was also actually thinking, oh, good, smooth guide. There is no friction actually. So there is no friction. Who on earth will stop this fellow? It goes like 3 feet per second.
What about
Okay, so it will be M A N, and we will have in the normal direction I have positive NN is equal to M V square over rho. So what is the value of radius of curvature?
There's no net tangential force in tangential direction.
8.
Cause the acceleration.
So it is
So it's zero. So let's assume.
3 square
That's what I'm saying. And there's always not a.
0.25 divided by 42.2. What is the value of V? How you figured? Okay, 3 square divided by 8 divided by 12.
105.
Good. His answer is correct. N comes out to be 0.1048 pound lb force. Now, is this the only normal force on the guide? By the guide? Well, I don't think so. It is equal to 0 because the guide is not flying into the air. That gives me positive Ny minus mg equal to 0. So my positive Ny comes out to be 0.25 pound force. This is first equation. Second, so what will be the reaction by the guide? Ahmed, this is clear, right? Ahmed, Mehmed, Hussain, Abdullah. Because
I'm just the overall here. I'm really confused right now.
what?
I'm confused.
Me. Here I used. Here I did not. Because you see that collar, when that collar arrives at B, there are two components. The fact that it is sitting on the slide, the fact that it is going in a circular path and it really wants to go away from the slide and the slide is really holding it. So because of that, I have NY because it is sitting on it. Because of the fact it's doing like that, you will have NN, the normal force, because it is touching the slide as well. Abdullah is smiling, huh? It hasn't even started its journey in the central part. They will on Acha, now your question is right when it has it passed A, will I have the same reaction force as B? From A to B. It should be the same. 100%. Okay, his question. Listen to his question. His question was the moment you have passed A.
Which acceleration? Why not?
Listen, please. The moment you have passed A, all the way up in that circular path, will the reaction offered by the guide to the slider, would it be the same? Oh, of course.
Yes.
But good, because the whole thing, if it's a circular path, then it will have two components, mv square over rho. Because at the end of the day, you have a normal force because of the fact it is sitting on it, and the fact that it really guide wants to hold it, and it is touching the slide. Yeah.
We said that total force at n axis equals n times an. So, for example, if we have like another force in normal axis, like FB, the equation be like n minus FB equals mv squared divided by r, right? So, yani, an is always equals to v squared divided by
Okay, listen to his question. His question is, what if you attach this collar with a spring, let's say, Izan? His question is, what if you attach the spring with the little collar? If you have a spring with the collar, it will do the same thing. But now if you have to make the free body diagram, you will have the spring force in the normal direction as well. So that will come into the picture.
So, yani,
That was your question, right? If I have another force, so I have added a spring to it.
yeah, I'm trying to understand that an always equals to v squared divided by r.
Huh. That's why, if you remember, quite a few times I have said in this class, around 95-99% of the times when I write summation of force equal to MA, I don't play with the right side, I play with the left side. There is just one thing that I want to mention. Yesterday I was thinking about it, that when I was going quickly last time, I think I did not mention one thing which can end up being a mistake. So I will just emphasize and we can call it a day. I hope you're feeling better about summation of forces. Now, you do need to realize that if you have missed any class, that's not my problem. In our classes, we have covered a lot of problems. Work energy principle, we did some good problems. We did that one problem in kinetics in which one mass was going down. The other mass was also going down, I think, summation of forces, we did that. That was a very comprehensive problem with friction, without friction. That was a kinetics problem, one tricky problem. If you haven't gone through it, then I don't know, you may struggle tomorrow, I don't know. So please revise everything. Okay, I will just revise one thing. Please bear with me, few seconds. Yes, the thing that I wanted to tell you was, which I am scared that today is 13, right? So our last class was on 10. Okay. Why am I offline? Okay. Okay, when was our last class? Can you please tell me? 10, right? 13. Huh? 10 or 9? 9. Yeah, this was his. Yeah, what my point is, if you remember, 9. Find the 9. There was. Okay, when I was doing this problem, do you remember I told you 1 meter per second, 1 meter per second, it goes like T, and what you have to understand is this is the conveyor belt. This is not the conveyor belt. So I thought that I should emphasize on this thing. This thing will go T, when it arrives here at 1 meters per second, now this package is on its own. So it will just go, it will just fall. That's why when you have to use this expression, ADS equal to VDV, now you need to remember that it is 1 meter per second here. And now this fellow is on its own. So then you have to solve it, put it into the equations. I did show you the previous semester's solution as well. So I hope you can do this problem as well. So the conveyor belt is still that portion. On that note, I think I'm pretty much done for the day. Do you have any questions for me? Should I do one more problem? Okay. I haven't made your exam yet, actually. I will try my best. Okay, everyone, it was nice having you. So yeah, okay, so please remember, this is what I told the class, that the conveyor belt is till here, and after that there is no conveyor belt, the package is on its own. And then I told you that for the solution, you can use this ADS equal to VDV, and you can solve this using this. Then you will get this expression. You can see I have cos theta max here sitting. You will have everything in the form of cos theta max. You will go back and you will put here inside this cos theta max. And you can find the value of theta max from here. Okay. Okay. We have, okay, I can discuss now any students' problems about my homework. Okay, we will talk about it. Okay, thank you. Best of luck. The contents included in the exam is already sent to you via O2 class announcements. You can read that. Marriage, let me pause the recording.